Okay, so let's look at our third and final way to do this. Let me actually move the recording window over a little so we can see exactly what I'm doing here. So the third way to do this, and this is gets pretty freaky, is to set up an alternate coordinate system. So where this is your y coordinates, and this is your x coordinate, and so x is along the slope, and then y is perpendicular to the slope. And then you've got a you've got a first thing you got to do is take your acceleration g, which is like that. Actually, let me make it a little longer than that. So this is g, and resolve it into an x and a y component, right? So this is our vector. Really, this is be a. I guess we can call this a. Just to call it a. This is the acceleration. It's due to gravity. Okay. So a equals, now the magnitude of this thing is g. So we have some angle that's, I guess we're going to have to call it phi is the angle of our slope. And we're going to find phi, let's see. So phi is going to be, the way to find the slope, or find what this angle is it's just d2 over d1 is the tangent, right? Rise over, or, you know, opposite over adjacent, whatever you want to call it. So it's the inverse tangent of d2 over d1. So, you know, that's one thing we can do there. And so here, this angle here is also phi. If you think about it, because it's, you know, this is parallel with this, and this, or yeah, well, this is perpendicular to the horizontal, and this line is perpendicular to this one. So if this angle is theta, then this, or sorry, this angle is phi, then this has to be phi here too. So let me see if I can draw a slightly better phi, somewhat better. Okay. So, what we want to do now, I'll switch back to purple just because I'm feeling freaky. So, this bit here, so say this is, you know, this bit here is going to be this you know, this part that's in the y on our red coordinates is going to be g cosine phi, and it's going to be negative g cosine phi, right? Because gravity is pointing down, and then this is going to be negative g sine phi. So we can put all this together, and I'll stick with the blue. A is negative g cosine phi. I'm sorry, this should be a phi, not a theta. My bad. So those are phis, not thetas. I bet you're losing me already, right? Okay, negative g cosine phi j minus g sine phi times I hat. Okay, so and see, now I've even done this backwards from the normal, so I'm just going to make this really spastic now and do this minus g cosine phi j hat. Okay, there we go. Now, so let's just do that. Now, you can see the disadvantage here, obviously, is that now you've got accelerations in both x and y. What's the advantage? What's the payoff to this? Well, the payoff to this is that once we find, we do all this conversion, we only have to look at the y, the y, you know, coordinate to find out how far we go, and then we want to find a distance in x. So this is trickier than, you know, this is trickier to set up, but actually you end up with a much easier problem in a sense. So let's take, I'm going to do this dark forest green here. So let's take and do our equations of motion x and y. So delta x, that's how far we come along this here, is going to equal velocity in x initially, right, times t minus, so plus, this is going to be plus the acceleration in x times, or sorry, actually that's not even right. Okay, so eraser, there we go. All right, so plus 1/2 acceleration in x times t squared. But the acceleration in x is actually negative g sine theta. So delta x equals vx naught times t, and actually the vx naught is going to be v naught times this angle here, which is theta minus phi. See, this whole angle here is theta, and this is phi, so this is theta minus phi, and I'm sure you can read that very well. So v naught times cosine theta minus phi t minus 1/2 g sine phi, no, not theta, phi t squared. Okay, and then delta y, I'm going to skip some of the intermediate steps here and just do v naught sine theta minus phi times t minus 1/2 g cosine phi t squared. So again, looks like a huge pain in the ass, and arguably it is, but what we want to do now is we can just solve for when let's go with oh, I don't know, how about sort of a purpley color. So now we solve for when delta y equals 0, and that gives us when we touch down. So suddenly this becomes actually quite easy. So delta y equals 0 gives us 0 equals v naught sine theta minus phi times t minus 1/2 g cosine phi times t squared. And the beautiful part here is this is where we can cancel a t and cancel a t there. So we get 0 equals v naught sine theta minus phi blah 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 minus 1/2 g cosine phi t. And then moving on down. Okay, so then t equals wow, I can't believe this is, I don't know if this is actually going to work, but 2 v naught over g times sine theta minus phi over cosine phi. Okay, and then we plug that into our x equation and we're done. So, well, I'll show you why in a minute. So delta x equals v naught, wow, this is going to be ugly. Okay, so v naught cosine theta minus phi times t, so it's 2 v naught squared over g sine theta minus phi cosine theta minus phi over cosine phi, okay, minus, wow, ugly, ugly, ugly. So, you know, I'm not even going to do this all symbolically. The point is, you can find your t here, and then you plug it into this equation, and you can find what delta x is. And the beauty of this way, which I'm not going to do, I said, but the beauty of this way is once you found your x here, that's actually your answer for part B, which you just wanted to find the displacement there. And then your c, which is the angle, was just this phi, which you found out anyway. So I don't know if that's actually easier in this case, but it's a different way to do it. And it's certainly, you know, in some ways it's easier to formulate. It depends sort of on what you like, what you find